Hey everyone, so this is our next section in Chapter 5. We're going to be looking at dividing polynomials. So Chapter 5 has all been about polynomials. We've added them, subtracted them, solved them, factored them. Now we're going to do long division of polynomials. And that's pretty crazy because we've never done long division of polynomials before. And what we want to start today's lesson with is just simply long dividing regular numbers, because if we can divide regular numbers, it is the same process as doing long division of polynomials, okay? So we kind of just want to refresh our memory with how to do long division of numbers, jot down the few steps, and then we're going to see how it applies to long division of polynomials. So let's just recall here. Let's look at this first example in this box. It says 985 divided by 8, which is the same thing, just to, like, all three of these things are the same thing, just written in different forms. So I've got the division bar, I've got the division symbol, and then I've got this long division symbol, and that's what we're going to be using here, and what we really haven't seen in a long time, okay? So let's check out. We're going to use this symbol when we do long division of polynomials. So I'm going to do 8 divided by 985. Remember what we do, okay? We look at this number on the outside and think about how many times does this number go into this first digit here. So 8 goes into 9 one time. So then I do multiplication. I do 8, 1 times 8 gives me 8. And then if you remember, we subtract. So I subtract straight down. 9 minus 8 gives me 1. And then if you remember, I bring down. I put that arrow, I bring down, and then I start it all over. 8 goes into 18 how many times? Twice, because then I'll do 2 times 8 gives me 16. Subtract, I get 2. Bring straight down, we get 5. 8 goes into 25 3 times. 3 times 8 gives me 24. Subtract, I get 1. There's nothing left for me to bring down. So if you remember, this is called our remainder. And we're going to talk about a couple different ways we can write the remainder. You might remember just writing like R1. Maybe you remember writing 1 over this number out front here, 8. That would be amazing. So a couple different things, how we've learned to write remainders. We'll talk about how we write the remainder with polynomials in a little bit. I just want to kind of summarize these steps for us. We first divide. Right, we do 8 goes into 9, we figure that division out. Then we do the multiplication. We do 1 times 8, gives me 8. Then we subtract. Then we bring down and repeat. Okay, so let's just practice again here. I've got 751 divided by 22. So if I have 2 digits here, I go to 2 digits inside. So 22 goes into 75 3 times. Then I'll do 3 times 22 gives me 66. Subtract 75 minus 66 gives me 9. And then I bring down. 22 goes into 91 4 times. 4 times 22 gives me 88. And then I subtract. Here would be my remainder. If you want to try these 2 examples on your own, you can do so and you can check them. Notice right here for number 3, I got 0 as my remainder. So what does that mean? If the remainder is 0, it means the divisor goes in evenly. The divisor is a factor. So think about, if we do 8 divided by 4, we get 2. Because 2 is a factor of 8, it goes in evenly. And that's really what division is, looking at factors. And we're going to remember that a lot. So different ways that we can represent the results. Let's think back to, let's just look at this one right here. Here. When I do that division, 751 divided by 22, when I do that division, my answer is up here, the quotient 34 is my answer, plus the remainder over the divisor, the number out front. So that's how we're going to be talking about and writing our final answer, remainder over divisor. So it's the quotient plus the remainder over the divisor. Or another way is, let's say if I had 751, we need to be able to see that if we do 34 times 22, and you can double check me on this, 34 times 22, and then I add the remainder to it, I still get my dividend. Okay, and the dividend is that number inside. We're going to talk about that right now. So just some vocabulary. Parts of a long division problem. The inside, I have the dividend. The divisor is that number out front. And then the quotient is my solution. You've heard of this word before. You know the quotient is a solution of a division problem. And then some representing the results. This is the exact same thing that I talked about right up above this. If I do the division problem, this is the division problem. Dividend divided by the divisor, it equals the quotient plus the remainder over the divisor. Or if I just want to look at the dividend equals the quotient plus the divisor times the divisor plus the remainder, and that's what's written right here. Quotient times the divisor plus the remainder. Okay, it's important to be able to see both of these forms. Okay, now let's start to we're going to look at, here's two examples. Just like we can divide numbers to find factors, we can divide polynomials by factors to find additional factors. So just a little interpretation of that sentence. I have 36 divided by 2. Okay, so then I do the division, right? 36 divided by 2. 2 goes into 3 one time, is 2. Subtract, I get 1. Bring down, 2 goes into 16. 8 times, I multiply, then I subtract, I get 0. So let's just note, here's the answer. Here's the divisor. And here is the dividend. If I just had 36 divided by 2, I knew 2 was a factor, and I couldn't think of the other one. Now I know that after doing this division, that 18 is also a factor. The other quotient, the quotient is a factor. So same thing. If I had this problem right here, x squared minus 3x minus 40 divided by x plus 5. So here's the first time you're seeing a long division of polynomials problem. If we divide this, the quotient is going to be a factor. If I do this division, my quotient is going to be a factor. And we've been talking about factoring all marking period long. So you can see when I do this division, I can then say if it goes in evenly, because it's going to go in evenly, there'll be no remainder, then my divisor and my quotient are factors of the dividend. Okay, and I'm just labeling these to help you out. Now let's practice, okay? Our first time ever doing a long division problem. There are a ton of steps, but I do want to point out we're doing the same exact thing as we do with numbers, okay? So follow along here. When we set this up, I have x cubed plus 5x squared minus 3x minus 1 divided by x minus 1. Okay, and we focus on the first terms, just like we did before. I'm going to look at x and x cubed. And I want to think about, okay, x times what gives me x cubed? How many times does x go into x cubed? And hopefully you're thinking of x squared, right? X times x squared is x cubed. Now we need to keep everything in line in nice columns of like terms. That's going to be really important when we do this. So I have to put it above the other x squared. I know we just divided it into the x cubed, but I need everything to be in columns of like terms. So we have to put it above the x squared. Remember, once we do the division, we are going to multiply. So I do x squared times x. That gives me x cubed. Notice like terms. X squared times negative 1 is negative x squared. Like terms. After we multiply, we have to subtract. Notice I put parentheses because it's really important to distribute that subtraction sign. So I now have x cubed minus x cubed. That goes away. That's 0. 5x squared minus a negative x squared. So two negatives become a positive. This is 6x squared, right? Because this is really 5x squared plus x squared. Once we subtract, remember we bring down. And then I start all over. Notice now when I start over, I still look at this number in the front, and now I look at this number. So I'm going to do x times what gives me 6x squared. That's going to be 6x. And again, I put that above my other like terms. I did plus because it was a positive 6x. And now we'll multiply. 6x times x is 6x squared. 6x times negative 1 is negative 6x. Parentheses, subtract. 6x squared minus 6x squared, that's 0. Negative 3x minus negative 6x. Two negatives make a positive, so it's really negative 3x plus 6x gives me 3x. And then I bring down minus 1. And then we start all over. Again, look at that number in the front. The x, notice I never look at that other constant. X goes into the 3x. How many times? X times what gives me 3x? Has to be a 3. Notice it goes all in line. My constants are on this line. And then we multiply. 3 times x is 3x. 3 times negative 1 is negative 3. Parentheses, subtract. 3x minus 3x is 0. Negative 1 plus 3 gives me 2. There's nothing left for me to bring down, so here's my remainder. Okay? If I write my answer to this division problem, here's the division problem. It equals the quotient, here's the quotient, plus the remainder, here's the remainder, plus the remainder over the divisor. Here's my answer with the quotient plus the remainder over the divisor. Also be aware that we can write it as the dividend equals the divisor times the quotient plus the remainder. Also be aware that this is true. Okay, I'm going to practice some more of these in the next video. This is just an introduction video on long division, and there's one example problem in this video. So watch the next video for more examples. Good job, guys, you got it.